Welcome to Statistics Learning Session. Today, I'll be talking about goodness of fit test. This is about probability simplex of a discrete distribution. So let's begin. We have a formal slide here, and this formal slide is about a mathematical expression about a discrete distribution to calculate the simplex of that. Here, we have E as a sample space. It is a realization of what? Can you tell me? It is a realization of our random variable x k times 1 2 3 2 k times, and that's why it belongs to sample space E, and it's a finite space. And it is saying that the probability of x being a1 is a p1. What is p1? P1 is the probability of x being a1. Probability of p1 is the probability of x being a1. That's all about it. Now, when we add all these probabilities, it should sum equal to 1, because that's what the law of probability says. All the probabilities should sum equal to 1 in sample space. And hence, since it's a discrete, each probability is a PMF of all the possible values the x can take. X is a here in x is a there are two of values x can take, and p is a probability of that. Now what we are saying is that there can be many sets of this. We can take many samples, there will be many probabilities, and eventually all the probabilities should sum equal to 1. All the probabilities should sum equal to 1. That's what it's saying here. And this set of all the probability vectors p1 to pk, many p1 to pk vectors, is called simplex. This is called simplex here. It is simplex of Rk, where k is a size of each vector inside the R. Now, let's take example of, just say we have only two realization, a1 through, let's say there are only two initialization of some random variable. You can take only two initialization of random variable. Let's say that. Let's assume, for example, and let that be x and y. Let's see, be x and y. And let's give example how this work is that this simplex work is that the simplex can be a line that goes across x and y, and where y is equal to x minus 1. That means x and y, x plus y will always equal to 1, and you can take many values on this line. And you see the most of this space is empty because we're constrained by y is equal to x minus 1. So these are all possible PMFs that can exist in a simplex of R. Now, let me quickly summarize what we learned today. We learned about discrete distribution, and there was a discrete distribution called E, and which had a plus a through k realization of some random variable x, and there's a probability of x taking each of the random variable, and there are also p1 through pk, and that sums up to equal 1. And there are many initialization that can happen in each random sampling, and when you add all these set of vectors, we commonly call it a simplex of k. And so that's about it. That's all for today. I'll see you next lesson. Thank you so much.